Now that we have cloned the Helm chats locally, we are ready to deploy both the Postgres and cronjobs. In this section, we will deploy the Postgres chats and explore basic Helm and Kubernetes commands. The first Helm command we will use is the Helm install. This basically installs the application. It takes a few parameters like which namespace you want to deploy into, values, but in our case, these are already defined in our Helm chats. Our Postgres Helm chat is located here. The Helm install command is pretty simple. Postgres here is telling Helm what to name the application. The last part of the command is where the YAML is located. So make sure that you're running your code from where it's located. Under this path, you can see the chat.yaml. Make sure you run your Helm install command targeting this exact location, or else it will fail. Now let's run the command to install it. The command failed because our Kubernetes instance is not running. This is because Docker Desktop has not started. Make sure you start Docker Desktop before you proceed. The Kubernetes engine is now running on our Docker Desktop, so we can go ahead and install Helm. In a few seconds, our installation is already complete. But just like in the real world, we have to validate. First, run the Helm ls command to see the list of all the installed Helm apps. One important thing about this command and Kubernetes commands in general is that you have to specify a namespace parameter. Since we did not specify a namespace parameter, we are choosing to list the apps in the default namespace. And so if your app was deployed in a namespace other than the default namespace, for example, your custom namespace called app, a simple Helm ls will not show your app because you did not specify the app namespace. We can see our Postgres installation here because we deployed it in the default namespace for simplicity. Next, after Helm installs your app, it deploys those Kubernetes resources which you specified or defined in your Helm chats. The most important one for us right now is the Postgres pod. This is the database running instance, and we will later bash into this pod to create a table in the database. Run the Kubernetes get pod command to see a full list of the running pods. Again, we didn't specify the namespace, so the pod that is showing has all the pods in the default namespace. We can see that the pod is running, which signifies that the app or the database is accessible. Let's run the get logs command to get the application logs. From here, we can see all the logs from when the pod was created until now. At the bottom of the logs, we can see that the database is accepting connections and is up and running. Another Kubernetes resource that was deployed is the persistent volume and the volume claims. This is the storage which the Postgres pod uses. The get PVC command gives us a list of the persistent volume claims, and the PV command gives us the list of persistent volumes. There are many other Kubernetes resources that were deployed after our Helm install command, but let's just focus on the pod and the PVCs for now. Remember in the Docker build section, we created some custom directories, right? Let's now bash into the pod and see the directories and script files which are now baked into the Docker image. We have now bashed into the running Postgres instance. Under the home directory is where we created these custom directories. Our scripts is located in the custom scripts folder. Now the basic ls command shows the files under that directory. We have the backup and the restore script. We can also cut the files to see their content. Remember in the Docker build section, we gave the user 1001 owner permissions to these directories. The reason why we did this is that the default user in the Postgres instance is the user 101. I used the whoami command to get this information. To further explain, when the Postgres pod runs the backup script, it also uses this user. Now that we have confirmed that the Postgres database is up and running, in our next section, we will create a sample table and insert some test data in it before we back up the database.